Hi everyone, in this section we will talk about vector data structure implementation. And what we need to do is firstly we are going to define a new kind of a data structure, so we can create a class whose name is vector, and later on we will create objects of this data structure of this class in main, and we will try to do some work with them, such as pushing some data into this vector or removing some data from this vector. Okay, so what are the operations that we are going to implement? So we are going to implement some of the common operations that this data structure supports. So one common such operation is pushback. If we have a vector that contains some data, we want to push a new integer to the last of this vector. So this operation is known as pushback. We can also do pop back. That means the element which is at the last position, we want to remove that element from the vector. So we will create a method that actually does this work, and we will also do the work for pushback. And if the vector is full, this pushback should also double the vector from a size of x to a size of 2x according to the logic that we have just discussed. So also we need to support a function, let's say get. I want to get an element which is at ith index, or I should be able to write v of I. So here we are going to overload the square brackets operator. Both of them are going to do the same work. Either we make a method or we do operator overloading. So whenever this operator is called with the integer, we will see, okay, we will return the ith element of the vector. Okay, so these are the few operations that we will definitely would like to have in our vector class. Apart from it, we are also going to support some of the functions like front. So it will tell us what element is there at the front of the vector. We are going to return make a function back that will tell us what element is present at the last position in the vector. And we are also going to make a function called size that will tell us how many elements we have in the vector. For example, size of this vector is 3, and we are going to make a function called capacity that will tell us what is the actual memory allocated to this array. So that is 6. Okay, it can store up to 6 elements. So let's see how we can do this one by one. Okay, so internally, as we discussed, these vectors are based upon dynamic arrays. And so when you make a class, what we define few data members that will contain the data of this data structure, and we also have methods that are defined on this class. So pushback, popback, getback, all of them are methods. Okay, and we also can define a constructor as well. Okay, constructor, destructor, copy assignment operator, all those things can be done, but we will just implement the most important methods that are going to be used commonly. Now if you are implementing a vector, you need to think how you are going to store the data in the vector. Okay, so one thing is very clear, we need a array. Okay, and this cannot be a static array. So we discussed it would be a dynamic array, because if the array is full, we need to change this array pointer to point to some other location. Let's say this array pointer is pointing to this one, but after some time this is full. I will copy the elements to a new location which is having a double size. Okay, let's say the original elements are 1 2 3 4, the new location is 1 2 3 4, and we put a 5 here. Now some of you may ask, why don't we expand the original array? Okay, so the reason is very clear. Let's say this array starts from address 100 and it ends at 120. So the next memory that is there, it is possible that this memory is already used by some other part of the program. Okay, by someone else. So we can't ensure that we already have free memory after this array ends. Okay, so we will look for new memory at some other location. Let's say this address is 800 and it ends at, let's say, 900, something like this. So we will allocate a new memory and we'll copy the elements from here to here. This is what we are going to do when we grow our vector. Okay, so one thing is very clear, one of the data member would be the array pointer that will point to the memory location. Okay, another thing that we can do is we can store how many elements we currently have in this array. Okay, so if this is an array pointer, and from this array pointer we don't know how many boxes we have currently used. Okay, maybe we can say cs is equal to 5. That means currently we have 5 elements and the next element will go at the 5th index. Okay, but this doesn't tell us when the array is going to get full. So we also need to store what is the maximum capacity of the vector. Okay, if current size is already equal to the maximum capacity, then we need to do the doubling operation. Okay, so if you maintain this much information inside your data structure or in your class, you can implement all of the functions that we have discussed. Okay, so I'm going to take 3 variables, one for the array, one for the current size, and one for the maximum size. So let's see how we can create constructor, destructor, other methods as well. So I'm going to keep these properties as private. I don't want that someone outside the container should know about how the container is actually implemented. Only what we want we want the main to use the functions to modify the data in this container. Okay, so firstly we will create a vector constructor. So by default the size of the vector is 0, and let us say the maximum size is 1. So by default when a new vector is initialized, I'm saying okay, I will just create array of size 1 and current size is 0. That means we don't have actually anything inside this array, and this array will point to a memory that will be of the type int, let's say, and the size is equal to maximum size. That's it. So this is our initially this is how the vector looks like. But now people say no, we want to push some data in this vector. So we can have method void pushback, and here we will get some data of the type D, and here we will write the pushback functionality, and we will have 2 cases. Okay, so let us write this functionality in the next lecture, and we have basic boilerplate code ready to keep it going. So let's see in the next lecture.